Everything you've ever been told about football talent is technically true, and also dangerously incomplete. In 2019, a team of sports geneticists ran full DNA panels on 120 elite professional footballers, players competing at the top 5 European leagues. Internationals, men who'd spent their entire lives being told they were exceptional. What the researchers found wasn't supposed to be headline news. It was supposed to confirm what sports science already suspected. Instead, it started an argument that still hasn't been settled, and that most people covering sport are too uncomfortable to actually explain properly. Almost all of them shared a variant in a single gene. Not a cluster, not a tendency, almost every single one. Let me tell you what that gene is, why it matters at the level it does, and why the most consequential part of this story has absolutely nothing to do with genetics. The gene is called ACTN3. If you've never heard of it, that's not an accident, because the fitness industry would rather sell you another training program than have you sit with what this gene actually implies. ATN3 produces a protein called alpha-actinin 3. That protein lives exclusively in one type of muscle fiber, fast twitch fibers. The ones that fire when you sprint, when you jump, when you change direction at full speed in the 88th minute with the game still alive. Those fibers are powered, in part, by this protein. And here's where it gets strange, not everyone makes it. About 1 in 6 people in Northern Europe carry what's called the X variant in both copies of the ATN3 gene, 2 X's. That combination, the XX genotype, means the body produces 0 alpha-actinin 3. None. The fast twitch fibers still function. The body compensates through other pathways, but they operate differently. And at the absolute extreme of human physical performance, that difference becomes visible, not in a gym, not in a training session, at the razor-thin margin where elite sport actually lives. In the general population, that XX genotype sits at around 16 to 18%. If genetics were neutral, if elite athletic talent were distributed the way hair color is, or height, or any other trait that doesn't track directly with selection pressure,
you'd expect that number to show up in elite athletes at roughly the same
rate. It doesn't. In the study of elite footballers, XX appeared in less than 2% of players. In Olympic sprinters and pure power athletes, some studies show it approaching 0. Across elite speed and power disciplines, the pattern repeats with unnerving consistency. The absence of functional ACTN3 almost never coexists with reaching the top. And here's the moment where most people's thinking goes one of 2 directions. The first direction, this proves talent is genetic. Effort is secondary, and half the motivational speeches in football history were something worse than lies. They were a story told to players who never had a real chance, to keep them in the machine long enough to be useful. Hard work doesn't determine outcomes. Selection pressure does. Your kid either has the variant or he doesn't. The second direction, this is reductive. Genetics is not destiny. This is the kind of thinking that gives coaches an excuse to write off players who just need different development, different time, different environments. Both of those positions are wrong.
The reason they're both wrong is the same reason the study nearly got buried before anyone
outside the research group saw what was in it. The researchers kept looking. When they broke down those 120 elite players by position, and this is the part that changes everything, the XX genotype didn't vanish uniformly across the squad. It was almost completely absent in wingers and fullbacks and strikers, the explosive athletes. The players whose primary value was measured in meters per second over 10 yards. But among central midfielders, among players in roles built around sustained aerobic output, positional intelligence, recovery between sprints, spatial reading, covering ground for 90 minutes without a single sprint that defined the game, the numbers were different. Not dramatically different. The distribution still skewed toward the RR genotype, but the XX variant appeared in some of the most decorated central midfielders playing in those leagues.
The variant that was supposed to eliminate you from elite competition
Was sitting inside some of the most elite players in Europe. That's the first crack in the clean story. Because football isn't sprint athletics. It isn't the 100 meters or the 40-yard dash or the combine test.
where a scout watches you run a straight line and writes a number in a notebook, and that number becomes your ceiling.
Football is 90 minutes of intermittent chaos. It's explosive acceleration for 2 seconds and aerobic recovery for 40, repeated 60 or 70 time match. The ACTN3 gene matters enormously for some positions, but for others, the XX variant might, and this is backed by secondary research, actually offer a marginal advantage in sustained aerobic efficiency.
Because fast twitch fibers operating without full alpha-actinin 3 can be trained toward endurance output more readily under certain developmental
conditions. The gene doesn't just code for fast or slow. It shapes which direction physical adaptation travels most efficiently. That is a fundamentally different idea than gene equals destiny. Stay in the lab for a moment, because the same study surfaced a second gene, less famous than ACTN3, but arguably more revealing about how elite footballers are actually made. The ACE gene, angiotensin-converting enzyme. It regulates blood pressure and cardiovascular adaptation, and it comes in 2 common variants, the I allele and the D allele. Which combination you carry influences how efficiently your cardiovascular system responds to training load over time. The 2 genotype turns up overrepresented in elite endurance athletes. The DD genotype appears more often in power athletes. And the middle version, ID, 1 copy of each, is associated with versatility. Bodies that can be pushed in either direction through training without hitting a ceiling too early in either domain. Guess which genotype dominated the center of the pitch among those 120 players? ID, by a margin that wasn't subtle. The central midfielder, the position that demands you be simultaneously tireless and explosive, covering more ground than anyone, while also being the one who has to win the ball back in the first second after losing it, was disproportionately populated by players whose cardiovascular genetics pointed toward adaptability rather than a single extreme. None of this was planned. No academy director was running ACE panels on 14-year-olds. No scout was asking for gene sequencing alongside a technical trial. What the study was capturing was the residue of an unconscious filtering process. Decades of competition, selection, attrition that had across thousands of youth players and hundreds of developmental decisions, converged towards certain genetic profiles without anyone knowing that was what was happening. Which is when the question you've probably been sitting with since the first minute becomes unavoidable. If genetic profiles are being filtered for, unintentionally, through natural attrition across 2 decades of elite youth development, what happens to the kid who doesn't carry the right variant? What does it mean for the 15-year-old at an academy who is working harder than anyone else in the building, who has more football intelligence than anyone on his age group, who will never quite hit the acceleration number that makes a scout write physical tools in the positive column? Here is where the science becomes genuinely complicated, and where almost all popular reporting on this topic makes a mistake that I think matters. ACTN3 and ACE don't operate in isolation. They're not binary switches. They're dials influencing, shaping, nudging probabilities that interact with hundreds of other genetic variants, with training history, with nutrition, with sleep quality across a decade of development, with the age at which intensive training first began, with whether you grew up on grass or concrete, with whether your first coach built your technical foundation before your physical one, or crushed both under conditioning volume at 13. A 2018 meta-analysis, pulling data from 17 separate genetic studies of elite athletes, found something that in retrospect should have been obvious.
No single genetic variant predicted elite status with reliable accuracy on its own.
Not ACTN3, not ACE, not AMPD1 or HIF1A or any of the other candidate genes that have been proposed over years of sports genetics research. What predicted elite status was combinations, polygenic profiles, not one gen, but clusters of dozens of variants interacting with each other and interacting differently depending on the sport, the position, the training environment, the decade. A player with the wrong ACTN3 genotype and exceptional long-term development could consistently outperform a player with the right genotype, and poor coaching right up until the level at which genetics becomes the binding constraint. That ceiling is real, but it's dramatically higher than most people assume, and most players, even most elite players, never get close enough to it for genetics to be the actual limiting factor. So what was the original study actually measuring? It was measuring the residue of selection. At the elite level, not the good level, the elite level. The players who remained had survived so many rounds of competition, trial, and development that their genetic profiles had converged. Not because genetics determined their success, because the system had unconsciously sorted for people whose biology allowed them to absorb a specific developmental load without breaking down first. The gene didn't make them elite. The gene made it less likely that the road to elite would destroy them before they got there. Consider what youth professional football actually is. A 10-year development pipeline beginning at 8 or 9 years old, running through academies, reserve squads, loan spells, first team competition, thousands of hours of technical training, physical conditioning, psychological pressure, performance scrutiny at ages when most children are still deciding what sport they like. The players who emerge from that pipeline at 21 or 22 aren't simply the most genetically gifted athletes who applied. They're the ones whose bodies responded to that specific developmental environment, at that specific intensity, across that specific time window, without catastrophic injury rates, without hitting growth plateaus that scouting couldn't see past, without burning out at 17 when the physical demands exceeded what their recovery systems could handle. ACTN3 and ACE aren't talent genes. They're resilience genes, in a system brutal enough that resilience looks identical to talent until you're trying to explain why the numbers converge the way they do. And here is the piece that, once you see it, changes how you watch a match. When you see a 23-year-old winger accelerating away from a defender who has trained just as long, who wants it just as badly, who made all the same sacrifices, and the gap between them isn't tactical, isn't technical, isn't motivational. You're watching a genetic difference expressing itself at the exact threshold where it becomes visible. That's not romantic. It's not comfortable, but it is real. And when you see a 33-year-old defensive midfielder who nobody has ever described as explosive, who never topped a sprint chart, who was never the most physically dominant player in any environment he entered, still dictating tempo, still arriving in position half a second before the situation demands it, still covering for teammates who are objectively faster. You're watching something different. You're watching a player who found the position where his genetic profile was irrelevant and built everything around that discovery with enough intelligence and enough years that the absence of one protein in his fast-twitch fibers became structurally invisible. That player exists. You've watched him for years without recognizing what you were actually looking at. The study didn't prove that elite footballers are genetically special in some simple, predetermined way. It proved that elite football is a developmental system that ends up, after 2 decades of brutal, unplanned attrition, selecting for a specific cluster of genetic traits, and that those traits have more to do with adaptability and resilience under stress than with raw physical gifts measured at 14. What we don't know, and what the researchers themselves flagged explicitly when the paper was published, and what no subsequent study has answered, is what the sport is losing in the process. How many players with XXACTN3 profiles were released from academies at 16? Cut because the physical metrics at 13 told a coach something that the player's football brain would have contradicted over the following 8 years?
How many players whose cardiovascular genetics pushed toward endurance adaptability were slotted into wrong positions at formative ages,
then assessed as not good enough at those positions? How much of what we're reading in the DNA of elite footballers is a description of who the existing development system was capable of producing, rather than who actually had the most to offer the game? That question has no clean answer. Not yet. And I think that's worth sitting with, rather than rushing to a conclusion that makes everything feel resolved. Because if you've ever been told your physical profile wasn't right for a position, or if you've been the person making that call about someone else, the honest scientific position right now is that we don't fully know what profile we should be filtering for. We know which profiles have survived the current system. Those are not the same thing. The gene is real. The clustering is real. The pattern holds across study after study in multiple countries, across multiple decades of elite sport. But the most important version of this story isn't about who has it. It's about what happens to everyone who doesn't. And whether football is yet smart enough to ask whether the system it built
To find the best players might be discarding some of them before they ever get the chance to show.
what they are. That question genuinely bothers me. If it bothers you too, drop it in the comments. Because I want to know where you land on this specific thing. Should professional academies be running genetic screening at youth level? And if they did, would that make the selection process more fair or just more ruthless? I don't have a clean answer. I'm curious whether you do. There's a follow-up to this I'm already building, about what happens when clubs actually do start using genetic data in recruitment, what the teams that have quietly piloted it found, and why the results were nothing like what anyone predicted. If you want that one when it's ready, the button's right there.